Welcome to How to Fly Using Your Alpha Systems Angle of Attack Indicator. Before showing the demo, first some basics for those who are new to AoA displays. The Greek letter, alpha, is used in aerodynamics to describe the angle between the relative wind, depicted here in black, to an airfoil's chord line. The normal useful angle in most general aviation aircraft is approximately 16 to 18 degrees, depending on the airfoil. On this coefficient of lift chart, increasing the AoA of the wing generates more and more lift at a given velocity until reaching critical alpha, approximately 16 degrees, whereby any further increase will generate less lift due to boundary layer separation from the wing. Please keep in mind that the stall begins at critical alpha, where your aircraft can no longer climb and the boundary layer has begun separating from the wing, and ends when you lose control of the wing. Here is a video of a wind tunnel model wing showing how the boundary layer separates from the wing and high angles of attack.
As the angle of attack of an airfoil increases, the flow in the boundary layer stops, then reverses direction. This is called boundary layer separation. As angle of attack increases further, the point of separation moves forward on the airfoil until it has so disturbed the flow around the airfoil that further increases in angle of attack produce less, rather than more, lift. In this condition, the wing is said to be stalled.
Let's now look at the Alpha Systems AoA Eagle display inside this Valkyrie heads-up display, or HUD. The Eagle display is very similar to the military-style donut display and is the most ubiquitous. The green bar at the bottom describes the AoA in the cruise phase, or angle. The yellow chevron and triangle are considered to be at a low AoA, or low alpha. The blue donut is what is considered to be the optimum alpha, where the lift of the wing is at its approximate maximum, but on the safe side of critical alpha. The red chevron and red triangle are considered to be high alpha. Optimum alpha is normally calibrated to be 1.3 times your aircraft's V sub S, also commonly referred to as your VRF, which is 30% prior to the stall point. When using your AoA on final approaches, your goal is to reach the blue donut, optimum alpha, and pitch to maintain this optimum angle all the way down final approach until the round out and flare to land. If your AoA increases beyond the blue donut, you will see the red chevron, which is effectively an arrow pointing downward, prompting you to lower the AoA, or lower the nose to get back to the blue donut. The red triangle is the calibrated stall point. For any given airfoil, all wings will stall at the exact same angle regardless of the weight, density, altitude, pressure, altitude, bank angle, or speed. However, your stall indicated airspeed will change for each of those, or any combination them. AoA is absolute. Once you've exceeded critical alpha, you are stalling. If the AoA gets lower, you will see the yellow chevron pointing upward to prompt you to raise your nose back to the blue donut. Pitch to maintain the blue donut, your optimum angle of attack. While pitching to maintain the blue donut on final, any throttle increase you make will cause your target landing point to move away from you, as long as you remain on the blue donut. Reducing the throttle will have the exact opposite effect and move your landing point closer to you, while maintaining optimum alpha. When you reach your round out to flare and land, you should increase your alpha into the red chevron with the goal of touching down when the red chevron and red triangle are both displayed. Let's watch a simulation of what this looks like with an aircraft already configured and established on a long straight and final approach. You will notice on short final the pitch attitude decrease while the AoA display stays on the blue donut. This is due to the throttles being decreased just prior to the landing phase.
1000. 500. 100 above. 200. 100. 50, 40, 30, 20, retard, 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 retard.
Now please answer this FAA question. If you answered C, you are correct. Not answer A, but initial climbs and or go-arounds, according to the NTSB. Therefore, using your AoA on departures or go-arounds is highly advised for keeping you safe from any stall spin scenario in the traffic pattern. As long as you remain no higher angle than the blue donut, you will always be on the safe side of the stall. During initial climb out, your blue donut is approximately equivalent to your VX climb, or your best angle climb, remaining on the safe side of critical alpha. If you know your GA aircraft's VY, or best rate climb speed, you can correlate it to your AoA display. VY climb should be someplace in the yellow chevron triangle region of the Eagle display. If you know what is represented on your AoA display for these two V speeds, you will find that many of the common GA aircraft's best glide speed is between the two, but not all aircraft. There are also many other GA aircraft with best glide speeds that are closer to the VY speed. Here is a FAA publication showing 3 common GA aircraft's VX, best glide, and VY speeds. Pause the video to have a closer look. Now, here are 3 more common higher performance GA aircraft added to the list. Note that the best glide speed is closer to VY, or slightly faster, meaning a lower angle of attack than VY. If you climb at your best glide AoA, or even your VY AoA, then you will already be at, or near an ideal engine out glide angle should your engine fail on departure. Please keep in mind that best glide AoA gives you the most distance for a given altitude. Max endurance glide gives you the maximum time aloft for a given altitude, not distance, and is also known as minimum sink. For all intents and purposes, max endurance glide using the Eagle AoA display would essentially be the blue donut, or optimum alpha. Lastly, if you happen to be flying aerobatics with an AoA, just remember not to pull the stick or yoke back beyond the blue donut where you have achieved maximum lift, but still remain on the safe side of critical alpha. This concludes the How to Fly Using an Alpha Systems Angle of Attack presentation. Now go fly and stay safe.